Dear student, today we are discussing about the complex number, and this is important for the board exam as well as a competitive exam. Today we are discussing only the important formula of complex number, and one by one we are discussing that. Suppose Z is a complex number and this is the a plus ib, whereas a is a real part and b is the imaginary part. So two part is there in the complex number, and this will be the ordered pair of this one. This is the ordered pair of complex number, and we can plot this according to the axis of x o x dash and y o y dash, and plotting the point this one, and this is a real axis and this is the imaginary axis. So the plotting of a complex number is that way. It may be the P point. Now this is the O to P. So this is the one kind of idea of complex number and their plotting also. And when we discuss about the conjugate of the given complex number, and this is denoted as Z bar and a plus ib. This is the a plus ib is there. Then we get the conjugate of a plus ib is a minus ib, and if this is a z, this is the z bar. So z and z bar conjugate to each other, and this is a plus ib and this is a minus ib. Now if we adding z plus z bar, then we get 2 times of a, that is a purely real. And when we subtract z minus z bar, then we get 2 times of ib, purely imaginary. So in that connection we can say the adding of a complex number and their conjugate is always real, and the subtract of conjugate of a complex number will be imaginary. Now in the next part we are discussing the modulus of z and the amplitude of the z. Suppose z is equal to a plus ib is a complex number, then mod of z will be root under a square plus b square. This is the modulus of the given complex number, and the argument of z, arg of z will be theta or alpha, and this will be tan inverse b by a. So argument of z will be theta or alpha will be tan inverse b by a, and similarly modulus of z is equal to root under a real part square plus of imaginary part square, but I is not there. And in this connection some important equation or inequalities is there. Suppose z1 and z2 is a two complex number, then the modulus of these two will be equivalent all the cases. This is the important formula for the complex number. And similarly some another formula is there. z1 z2, modulus of z1 z2 will be equivalent to this. So these two are the important formula for the complex number. A plus z is equal to b. Max of this will be b plus this one b square plus 4a by 2. Mean of if modulus of z plus a by z is equal to b. Then the max of z will be b plus root under b square plus 4 times of mod of a divided by 2. And similarly, mean of mod z will be minus b plus root under b square plus 4 times of modulus of a divided with 2. This is the max and the mean formula of z from when this is the given. And now the next and the last part and the formula we are discussing about the q root. Suppose aq is equal to 1, then we get aq minus 1 will be 0, then x minus 1 and x square plus x plus 1 will be 0. Either x minus 1 will be 0, that is x is equal to 1, and or x square plus x plus 1 is equal to 0. Then by the Siddhar Acharya we get minus b plus minus root under b square minus 4a into c divided by 2 into a. That is a 2 into 1. After calculating we get minus 1 plus minus root under, this will be 3i square divided by 2. And now the x will be minus 1 plus root 3 I of root 3 by 2, and similarly minus 1 minus root 3 divided by value of x is there, and this will be considered as a omega and this will be considered as an omega square. So if we put omega is there or omega square is there, then we get 1 plus omega square will be 0, and omega q is also 1. If we put omega, x is omega is here. If we put omega is here, then omega q is equal to 1. So these two is an important formula for the q root. This is the complete of formula section. This is the complete of today's discussions, and we discussing about the complex number and the important formula.